Okay, so I'm going to go over finding limits graphically. I've been procrastinating on making this video, but so I drew this graph of R of t. You can see it on the screen. And we're just going to go through and we're going to find some of the limits, not all of them. Some of the other ones you can find on your own. But let's look at what's happening as x is approaching -1 from the left and the right and so on. So if we look at where our x value is -1, I'm going to do it in green. We're at -1 right here. And so the question is, as we get closer to -1 from the left, that's this first limit here, what is our function approaching? So as I come from the left, so I'm going on this line right here, what am I getting really close to? What output am I getting really close to? Well, I'm getting really close to 2. Okay. And then if I come from the right, so if I come along this part of the curve, as I get closer to -1, I'm getting closer to -1, even though we never touch -1. And -2 is not equal to -1, so that means that our one-sided limits do not agree. And so this whole limit does not exist. And then because I still want us to be familiar with what is the function's value, at r of -1, we're looking at the closed dot. So at r of -1, we have a value of 2, an output value of 2. Okay. And moving to 0, if we come at 0 from the left, let's do, hopefully this color is different enough. If we come at 0 from the left, we end up going down forever and ever and ever. Well, that's -infinity. And I'm actually going to pause here and say something that I didn't say in class because it's it's kind of finicky, but technically this limit right here, I'll rewrite it down below. We'll not do white, we'll go purple. Technically this limit, as x is approaching 0 from the left of r of t, you could also say this limit does not exist. Because infinity is not a number, and our limits are supposed to be a number. But this is where mathematicians get a little weird with notation, because the limit does not exist, but it gives us more information to say that it's approaching -infinity than it does to say the limit doesn't exist. Because the limit not existing could mean a bunch of different things. So when we can say something specific, we do, but technically that limit does not exist. And the reason I say that is because now that I've said that technically this limit does not exist, that lets us know that immediately our two-sided limit also does not exist. But we can go through and we can sort of check that still, just to make sure. And I didn't say that in class because I thought it might be confusing, but if you're watching the video, you can get that little extra bit of information. But now if we approach 0 from the right, we're going up to +infinity. And then we can also say, we can look at these two one-sided limits and we can say -infinity is not the same as infinity. Those do not agree, so our whole limit does not exist. You can also approach it that way. Okay. And then if we're approaching 5 from the left, we'll do blue. I haven't done blue yet. 5 from the left. we're approaching 4. And then we do, have I done this color? I have done this color. 5 from the right. That's also approaching 4. So since our one-sided limits exist and agree, our two-sided limit, our normal limit is 4. And then again, just to practice checking a function's value, at r of 5, we have an open dot. Our function is undefined. Function values do not exist. We don't say a function value does not exist. We say a function value is undefined. Okay, and that's finding limits graphically.